This question is a good question which highlights uh, which all formulas to use for finding the pH at various state of titration. So let's commence solution of the question. It says what? It says that a weak acid Ha reacts with NaOH. Of course, it will give salt plus water, which is NaA plus H2O. Equivalent point was reached when 40 ml of 0.1 molar NaH was added. This was 40 ml of 0.1 molar, which means in terms of millimoles it would be 4. Now at equivalence, of course, Ha added would also be equal to 4. So at the end of the titration, we will have this as 4 and this as 4. It has no meaning because water is always present in excess. So we have 4 millimoles of a salt of strong base and a weak acid form. Now what says this was the scenario number 1. Next what happens? Second. Now 20 ml of 0.1 molar HCl were added to titrate solution and pH was found to be 5. This is titrate solution which contains 4 millimoles of NaA. So we have NaA plus HCl. It is going to react giving us what? NaCl plus Ha. How much was this? This was 4 millimoles. How much is this HCl added? This is 20 ml of 0.1 molar HCl, which means 2 millimoles. So at the end of the reaction, HCl is consumed, right, giving rise to this. This is a salt of strong acid and strong base, so the pH hardly changes because of this. So, and what remains is the weak acid and its salt. So it's a case of a buffer. We'll use the buffer formula. pH is equal to pKa plus log salt. Salt over here is NaA upon Ha. And since the concentration of this and this is same, this is also 2 and this is also 2, this becomes log 1, which is equal to 0, which means pKa should be equal to pH, and pH is given to us as 5. Next come the third stage and the final stage of the question. It says what will be the pH of solution obtained by mixing. Now we have a new scenario which is NaOH and Ha. How much we are adding for this? This is 20 ml of 0.2 molar, which means 4 millimoles, and Ha added is also 20 ml of 0.2 molar, which means it is again 4. So at the end of the reaction, we will have a salt formation, which will be 4 millimoles, right? In 40 ml, 4 millimoles in 40 ml, because we have 20 ml of this and 20 ml of the acids. Now this is a salt of a weak acid and a strong base. So for finding pH, we have a direct formula: 1 by 2 pKw plus we have pKa plus we have log C. So it becomes 1 by 2 pKw is 14, pKa we have found is equal to 5 plus log C. The concentration is reduced to half. Why? Because equal volumes of acid and base were added. So concentration is 0.1. The log of 0.1 is -1. So here we have, this is 18 by 2, which is equal to 9. So pH of the required mixture will be equal to 9, and hence option would be B for this question. Thanks for watching video.